Hi, young men, young ladies. Are you stressed by maths? One thing I like to tell you, maths can be really fun. Put your heart into it, enjoy every moment of it. And you know what? Maths is one subject that you can watch TV, you can listen to music, and yet do maths. You kill two birds with one stone. But that can only take place if you know your substance. If you know your maths, you know the concepts, then go ahead with dual activities, all right? And you'll find time flying. And amazingly, while watching a movie or while hearing your music, you are also having lots of sums done. And well, today, what I'm going to do, practice maths. Look at the sums that's given to you, and then you follow through, and you'll be amazed when you check it out with my solutions and yours. Of course, after what you've done, you look at what it is, you will be really pleased. So please look at the problems, the graphical graphs and its graphical solutions, and you'll be a master of graphs. Now the first sum that I gave you was this. You know something? This is a simple graph. But yet, there were some parts of it which might shake you a little earlier on, but I don't think so much now. But let's find out, alright? Let's go on to see if you're on the right track. Now draw the graph of x squared plus 2 over x minus 1, where the range of x is given. The range of x, what do you call that? Letter D. Domain, yes, that's the range of x. You call it domain. The domain, if I were to spell it for you again, D-O-M-A-I-N. The domain of x is between from minus 3 to 2, inclusive of both ends. Now this graph, if you look at it, please look at it carefully, and you can see this question. It tells you that it is a quadratic. Smile, frown, smile, because positive x squared, excellent. When x is 0, it cuts at, your y will be at minus 1. Great, I think you're getting quadratic right in you. Now let's look at this from the simple graph. Later on we'll progress to more difficult ones, alright? But my worry and my concern is the later part. Have you mastered it? So that's why let's go on to it and find out. You take your values of x from minus 3, minus 2, minus 1, 0, 1, 2. Because it's a curve, you need at least 5, 6, 7, 8 points. Don't put 20 points, please. You're going to waste your time. Alright? So just about 6 to 8 points will be good. Now when x is minus 3, fit it in. All these values fit it in, and you get your reading. So your reading will be, you will get a 2, yes. And here will be a minus 1, a minus 2. You would have got that, and you would get a minus 1, and the last two readings you would have got is a 2 and a 7. You would have got that. Alright? Now, you would have done, what you would have done is you would have put in the value of your x into the equation, x squared. If your x is a minus 2 times minus 2 is a 4. 4 plus 2 times minus 2. Here will be again, you will get a 4 minus 4 minus 1. So 4 minus 4 minus 1 will give you a minus 1. Similarly with all the others. I think you would have a problem in that right now. Next, you have to find the solutions of the graph from the graph. Alright? What are the solutions for these two parts? So let's draw the graph first. What is it like? If you look at your reading, the highest point is 7, the y. The lowest point is a minus 2. So your y-axis will stretch from 7 to minus 2. As for your x-axis, it's from minus 3 to 2. Alright, so you draw your scale. Normally they will tell you like 2 cm for 1 unit in the x-axis or whatever. Just follow that. And if you're not very familiar with that, you want to alter it to what you're comfortable with, you may do so, but at the expense of losing some small marks. Alright, rather than you not doing the graph at all because you're unfamiliar with that. No such thing. Alright, okay, let's get to it now. When x is minus 3, hey, where is y? When x is minus 3, look at it. Y is a 2. X, y. Mark that point. When x is a minus 2, hey, x is a minus 2. Y is a minus 1. It's going down this way, minus 1. That's your point. Alright? When x is minus 1, y is a minus 2. Go down, get that. And when x is 0, y is minus 1. When x is 1, y is a 2. And when x is 2, y. Alright, draw it with a ruler. Get it right there. Right. Now, what you need is a steady hand. Alright? If you want a curved ruler, you may want to. But I'll be very frank with you, I seldom use it. Or I can say very often, I never use it. Right? Steady hand and join the points. In your graph papers, I said small, neat, easy. You can do it even better than I do. Right? Join from one point to another point. Here again. And you look at this and you say, hey, you. And this goes down here and you join. Do you see we've got a lovely curve? Alright? Okay, you can sometimes there is a little bit more dip. You want if it's not symmetrical enough. So look at the drawing and see it. As long as it's a quadratic, alright, your curve is a parabola. And all parabolas will have a line of symmetry. This is the line of symmetry. Or if it's a peak, you have a line passing through the minimum point. Now, so that's going to be around the minimum point. And I think I've not asked you for the least value, no doubt, all right, the question. But we can work out the least value using the value added information, completing the squares. Familiar with it? I don't want you to get away from it. That's your side working, all right, to counter check. Okay, now what is it all about? You look at the formula again. Y equals to x squared plus 2x minus 1. Now I'm going to put this here, Alright, we take out one that's out, x squared, and this is a 2x minus 1. And if I were to take a half of 2, remember in completing the square, we take a half of this, we get a 1, we square it outside. And then we've introduced a stranger, remember the 1 there? The stranger is always this 1 squared times 1 is a 1, a plus 1. And what do? We take that away. We plus it in there. Remove it now. So we've got y to be equal to x plus 1 squared minus 2. This is called completing the square. And it tells you very clearly the minimum point because this is positive 1. It's a minimum point. And the minimum point is when x is minus 1, y is minus 2. Did we get that? Yeah. You saw that? So what we're doing is that's arithmetics. You're getting the minimum point by calculating, completing the square. That's a value add information. We keep it at the side. Whereas this is your graphical solution. Alright, you've got a minimum point. I'm just adding on to build up your understanding of this question. We've got this minimum point, x is minus 1. We can draw the line of symmetry. Look at that. I missed it. Have your ruler, my dear. Alright, this is minus 1. Your line of symmetry will go right smack there at minus 1 here. This is minus 1. Your line of symmetry will show you an equal distance, alright, from this point here. Your x stretches equal to this stretch here. Take note of that. Alright, your stretch of your x. So that will give you your line of symmetry. Let's go back again to a question. Now they have drawn the graph. They tell you, A, when is x squared? Please label clearly. B, part 1, x squared plus 2x minus 3 equal to 0. If you look at this question, what you are given, this is not y. The y is supposed to be x squared plus 2x minus 1. You've got to give birth to y. How does this birth take place? Y. Please, it's not easy, you think so? No. The word birth may frighten you, but it's just the birth of y. Alright, let's have it. We have a x squared plus 2x. It's in y, not minus 3. So if you put a minus 3 here, you get a 0. But you want this to be a minus 1. What do? Yep, you add a plus 2. So you add a plus 2. So what you get is your x squared plus 2x minus 1 is equal to 2. This is none other than y. Your y is equal to 2. My dear, what do you do next? Y is 2. This is none other than y is 2. What is x when y is 2? Look at the line, A, y. You are 2. Draw the line, y equals to 2. Read the solutions when y is a 2. You can see that when y is 2 graphically, alright, when y is 2, x is, yes, minus 3 and 1. X is minus 3 and 1. These are the answers. Please take note. Now the second question, what is it? Alright, they tell you, hey, x squared plus 3x is equal to 2. When you look at this and you say, oi, that's not y. We have to do a surgery to get y. The birth of y. What is the birth of y all about? It has a 2x. So just write that first down and then do the necessary alterations. You've got to change this to a 2x. What you do to your right hand side, left hand side should be done to your right hand side. You want to change that to 2x. You want to minus an x. Great, you do that. So you've got x squared plus 2x. Now what else do you need to do? Oh, you got to do a minus 1, you see? There has to be a minus 1. So you add a minus 1 here and you add a minus 1. What you do here, you do here. So your equation will be x squared, 3x minus x is plus 2x minus 1. And 2 minus 1 will be a 1 minus x. You saw that? So you've got the equation now. You said, oi, hello, your y, and your y equals to 1 minus x. You got? And that's what you've got to include. The best suitable graph that you need to put in for this is y equals to 1 minus x. And that will give you your graphical solution. Confident? Getting better? Yes. Just looking at that alone has got no solution. You would scratch your head. I can't do it. But now you know it. I've got to create a y. Tell yourself, how do I go about it? Do it right. You got to say, A, what's not there got to be removed in some careful ways. So do it right and you get it. Now you see this graph in part 2. You need to draw this graph, y equals to 1 minus x. As I said, or you can put minus x plus 1. Alright, minus belongs to x. The gradient, remember a straight line has a gradient. What is a straight line? Y equals to mx plus c, where m is the gradient and the gradient of this graph is a minus 1. Now, is it going to be difficult drawing this graph? If you do, I will be really disappointed. Is it difficult? No, right? In a straight line, you know the gradient, you know the intercept. The y-intercept is 1. So, draw it. How many points do you need? 3 points. But we can also draw it with 2 points if you're confident enough. And what will be your best point? X is 0. X is 0, y is 1. Great, that's 1 point. Next, y is 0. When y is 0, alright, look at that. Your minus x plus 1. Bring your minus x over. Your x is 1. When y is 0, x is 1. So you've got this lovely straight line. And the name of this graph, y equals to minus x plus 1. Just draw it across. Alright? Draw it across and you've got that straight line. Now the solution lies somewhere around here because we want to find the graphical solution. And you can see that it's almost half. Do you see that? So the solution in part 2 will be when this is happening, your x is equal to, yes, half. Alright, we've got that as the solution. Now we can do a little test. Is it right? Alright, as I said, graphical solutions may not give you 100% accuracy. Because can your eyes, are they magnifying glass to see that clearly? Number 1. Number 2, alright, some scales, alright, is so it's not as a simple whole number. Alright, some of them have got fractions to the 2 decimal place, how many we don't know. So we can only see what we can with a human eye. Alright, but we can also test to see how far off we are. And I told you how, not that we want to cheat, we want to see how accurate we are. So we can do a little check. Alright, we're going to do a little check here. In x, the solution for it will be x is equal to half. Alright, a check for part 2b. And I just want to see how far off we are. We said that x is half. So we put into the equation of this curve, y equals to x squared plus 2x. This is the name of the graph, right? But we want to do a solution to this. X squared plus 3x is 2. Is it so? When x is half. Alright, we want to find out half squared plus 3 times half. What do we get? This is a quarter plus 1.5. We get 1.75. We are a little out. Alright, as a quarter, this 1.5 is almost 2. It tells us that this answer is a little off. It can be about 0.6. Perhaps you can try it out. But for my eye, in my graph here, it looks like 0.5. Anybody got better answers than that? 0.55? 0.6? That would be good. Alright? Because as I said to you, 0.6 would be more accurate because I was just reading from not a very well calibrated graph. Alright, next part. From the coordinates of the point, let's look at again. Keywords. Sometimes wordy sums may put you off because of many words there. So what you've got to learn is to look for keywords, identify them, and that will make solutions a lot more easier. So let's go through. Find the coordinates of the point at which the gradient of the tangent is -1. They want the point on the graph, my dear, when the tangent is equal to -1. That means the tangent is a line and it's touching the curve at one point. And at what point is that tangent where the gradient is a -1? Do you see this? Look at this again. What is this gradient? The gradient is -1. We just talked about it. So, but this is just a line, right? We need to find this line which is moved. Just move it. It's a parallel line. Look at that. Move it where it cuts at a point where the gradient is -1. Use two rulers. Put one ruler here. One ruler, you place it here. Another ruler diagonally across, and move it along with the other ruler to see where it cuts it at where the gradient is -1. Could you try that? Yes, did you do that? And if you moved on, and you would see that when x is going to be -1.5, you would see as it cuts. Alright? I wouldn't try to take a risk of it. All you need to do is, right now I just don't have the help of rulers right now. Alright? I'm just going to take two books and I said, hey you, this is what it is. And I'm going to place this, imagine these are two rulers, like this. There's one ruler, this is another ruler. And I just move and I say, hey, and I draw that line across. I move this line, this is a ruler, I leave it, and I move this, and it cuts at this point. Got it? Alright? I've got one ruler and another ruler. I take this and I move it, and then I draw that line. And you'll see that it will be somewhere around here. Alright, at this point. And these two lines are parallel. They are parallel. And it cuts around here where x is equal to -1.5. And you can see a y is somewhere here. Read across it, and that's about 1.8, -1.8. So in question C, the gradient is equal to -1, alright, when x is equal to -1.5 and your y is a -1.8. Alright, look at that, -1.8. You can write it as coordinates this way, x, y. Alright, now these are the little challenges that you see, but isn't graphs getting easier? Get to your next exercise, the next sum in practice.